Oh, we're live. Are we recording?
No, we're not recording.
Ah,
But it's we're live. So
okay.
all right. And now I'm recording.
Hello, I'm Dan Sullivan today to give the ePMP Now presentation on modes of operation. Modes of operation is how ePMP meets your individual needs on whatever use case you can throw at us in point to multipoint or point to point. I'd like to think of us as like as the ePMP Army knife for any kind of mode of or use case or operation you would like to do. Here, if you can do the slide really quickly, I want to show the SM as the Swiss Army knife. All right. So just like a regular Swiss Army knife, we act just like it in how we meet your use cases, and that's the topic of today's presentation. All right, the first use case, single sector. You got that single sector, get this beautiful valley. I wish all the valleys in the world were like this. You got the farmhouse really close to your access point, and you got the little village further down. You got other subscribers on the way, but you're all by yourself, and so you got this one access point. So how does ePMP optimize its different a selection for you so you can optimize the throughput experience and latency experience for your users? What we do is we use flexible mode of operation. And in flexible mode of operation, we use our tried and true TDD frame, but the beauty of flexible mode of operation is it will dynamically adjust the throughput to the downlink and the uplink as there is demand. So if a user is doing a big time download because they're accessing some kind of website, then you'll give all your output to the downlink. If there's, for instance, some video traffic going on the uplink, you can then optimize your uplink traffic too and have that filled in there also. So the other thing with that is if there is nothing going on or minimal things in one direction or the other, you'll minimize the size of the throughput going in that direction. Okay? And what that does is that helps us to have decreased latency so that the overall experience for each user is optimized both with throughput and latency. Now what I'd like to do is kind of capture on the board these different use cases and what things that we have to meet them, with the different benefits we have to meet them, and then what mode of operation or our tool, Swiss Army knife, we have to address it. So the first one we have here, we just talked about, is our nice single sector solution where we have no need for any other sectors. And typically latency in this case is optimized at 7 to 8 milliseconds. Okay? And then throughput can approach approximately 100 megabits per second both in the downlink and in the uplink when you favor a specific direction. Okay, we can support both point to multipoint and point to point in this operation. So if you have single sector, the mode of operation to use is flexible. And these are the benefits you get in the middle. Okay. Our next mode. All right, say I got the traditional use case where I'm covering a large area and I'm up on a tower, or I have several towers. Here's a small Midwestern city, maybe like 5,000 people. You might have 3 or 4 towers to cover this city. And so what you do on the different towers is you frequency plan. And we come to here with our multiple sectors. It's perfect for using our GPS sync solution that ePMP provides. GPS sync, just to remind everybody, we coordinate when we transmit and when we receive. And that way we can co-locate our access points together and minimize the amount of channels that are used. Okay, so normally on a tower, a 20 megahertz channel, what you can do now is you can have an AB scenario like we have here on the slide. And it's only 20 megahertz a channel for A, 20 megahertz a channel for B, and a 5 megahertz guard band. And then if you have multiple towers, like we talked about here, sites, you can frequency plan with AB, CD, CD, and optimize how you use your frequencies within an ePMP system. The beauty of this is because you're planning your frequencies through GPS sync and able to reuse your frequencies, the amount of bits that you get per hertz, or the amount of data you send over your spectrum, is greatly increased. So instead of needing like 4 separate channels separated on an AB solution, separated by guard band to 40 megahertz, now you have 2 channels with the guard band separated to 5 megahertz. So what is the benefits for this next use case here? Let's cover it out here. Summarize it here. We have multiple sector and we go into using our frequency reuse of AB, we're using GPS sync. Now with GPS sync, because we have the synchronization, it's a 5 millisecond frame, latency is typically somewhere in the neighborhood of 15 to 18 milliseconds, and the throughput is tailored to each direction. So the beauty for the single sector and for flexible mode is it reflected what's needed in the downlink and the uplink. And for this mode, we have a fixed ratio, and I'll show you these shortly. And it's slightly less than the approximately 100 megabits per second of either the downlink, uplink. I'll show you the quantities later on. Okay, but where we really shine here, is now we get 8 bits per hertz for a multiple sector solution. Whereas if you had to do a single sector flexible mode, you would only get 2.2 if you had to find 4 separate channels there. So very highly efficient, saves your spectrum, so you can put up more and more APs and more towers. It also supports PMP and PTP. And once again, this is our fixed frame mode of operation. This is our solution to multiple sectors. Okay, now we continue to talk about why we would have multiple sectors and the different cases of multiple sectors and the different uses. One use might be you have mainly households and they want to have their throughput sent to them. They want their video, they want their internet, they want whatever that they want. Downlink is everything. The second one is you might have some use cases where you're doing video surveillance, and then the direction of the throughput is totally opposite. It's the uplink. I want my video, I want it going up, that's all I really need. Downlink isn't so much. Finally, you have some cases where you might want it all. You might want like the downlink, you might want the uplink. So ePMP provides you these tools to support this, and we do this through different downlink and uplink frame ratios. Okay, so what we have here is we have 75-25 to favor the downlink, and you can see that our frame that we send every frame, the 5 millisecond frame or 2.5 millisecond frame, it favors that for the downlink. We kept 50-50 for the use cases where you have both downlink and uplink. And lastly, we have 30-70 if you have those cases like where you're doing video surveillance. Okay, so if I go through here, we can now show under here sub-use cases of the multiple sector. So we have the home, and of course we're doing this all keeps coming down here. Same latency. And then what we have here is you might have downlink throughput of 85, and uplink throughput might be somewhere like 20. Okay, and similar things here is this 8.0 is still coming down here. So maybe I'll just kind of show this for right now. We'll just show the arrow going down. And similar right here. Okay, and so what mode of operation this is fixed frame, but now we have the 75-25 frame size. Okay. When we go to the strictly video use case that I showed there, I mean the video surveillance, right? Let's just do this. We'll say this keeps going down, right? This goes down. Now what we have here is we have somewhere like in the range of 58 in the downlink and 58 in the uplink. Bits per hertz stays the same. We can still support point to multipoint and point to point. Here we have our 30-70 option to meet this use case. And lastly, if you have the mixed here, Everything still holds like we had before. And here we have up to like 35 in the uplink or downlink and 75 in the uplink. And this is our, shoot. Mixed these up. So sorry, everybody. 35, 58, 75. And this is 58, 58. And so here we have our 50-50 use case. Okay. Now, what if, in addition to all these good things that multiple sector has to offer, you want decreased latency? I might have a lot of gamers for some reason, like maybe I'm servicing a college campus or something like that. So what do I do then to satisfy that use case where, bam, latency is so important to everybody? What we did with an ePMP is, in addition to the 5 millisecond frame, we came up with a 2.5 millisecond frame. There's two benefits. The first one is if you have some FSK equipment, you can co-locate with that because they use a 2.5 millisecond frame. The second benefit, though, is that the smaller frame size allows you to have decreased latency. At the expense of a little throughput, but the decreased latency might be important to some users. So what is the benefit of the decreased latency? So now we have another thing where we have decreased latency. All the goodness for frequency reuse still is there, of course, but now our latency goes down to 9 to 10 milliseconds. So from going down from 15 to 18 to 9 to 10. 15 to 18 is still great in a synchronized system because when you scale on a free 15 to 18 milliseconds and you go to higher and higher subscribers, it stays the same. It doesn't grow. Here, we hold at the 9 to 10. Now, on the throughput is approximately 10% less than 5 millisecond frame size. Okay? Because what we have is we have 2.5 millisecond frames and we have double the latency overall, as we show on the slide. Here we still have the same benefit of the 8 bits per second, and we still support point-to-point, point-to-multipoint. So what we have really right here is now we have our 2.5 millisecond frame size to handle that use case. All right. Now, the last thing is, what if I want a really fast and a really low latency point-to-point link? And we have a solution for you there too. So on all our other stuff where we do flexible mode and we did the fixed modes, fixed frame modes, they all support point-to-point, and you get that. But what if you want the best of everything just with two links optimized to each other? And that's what we have. So we call this our optimized point-to-point, ePTP. And what we did is we used the CSMA, CA, the Wi-Fi solution for this, but we manage our collisions, we minimize them. So the result of this is that we've minimized latency and we have high throughput. Okay. The only caveat is please make sure that your links are below 50 kilometers. Okay, so now we have the use case of fast point-to-point. And with this use case, we can get latencies down to 2 to 3 milliseconds. And your throughput is very high. Let's just say it's like we had in the flexible mode, approximately 100 in the downlink and the uplink. And this use case here we solve with ePTP. So there we are. Okay. Now, last mode that we have is we have the ability to provide migration if you have existing non-ePMP products and they support Wi-Fi mode. So what we do with that is we have the ability on your access point to put it into Wi-Fi mode, or we give your subscribers the ability to go into Wi-Fi mode. So in either mode, what you can do is you can convert your existing network to a Wi-Fi based solution. And then what you can do is you can introduce your ePMP units. And once your ePMP units are introduced, and you can start to replace the existing units with ePMP, so you have an orderly migration You don't have a long downtime for your users. And then when you're all done, you can convert to the TD mode of operation. All right. Well, that's all we have today as far as the modes of operation. And I wanted to thank you for your time and understanding how ePMP can meet your needs as far as various use cases that you might have in your use of our products.